So we're going to talk a little bit about graphing in this new unit. And just for today, we're going to just look at what graphs look like in the coordinate plane and how to describe what happened to them. So mainly describe, did they go from the parent function, which would be like the original? Did it go left, right, up, down? Like what directions did your graph go in? The first one I want us to look at is this equation that says y equals absolute value of x plus 1. Does anyone remember what an absolute value graph looks like?
No. Is it just like
a line?
Kind of.
A dot?
It looks like a V. All absolute value graphs look like V's. So the parent for an absolute value graph starts at the origin, and it would go up to the left and to the right. Because anything that you put into absolute value is positive. So even if we're putting in negative values for the x, and whether you get like a negative or a positive inside of the absolute value, your answer is always going to be positive, which is why it goes up in both directions. The only time that it would flip directions is if there was a sign on the outside of the absolute value that forces it to go negative. So if I want to graph an absolute value function like this one, y equals x plus 1, you have a couple of options that you could do this. You could try, if you know what the parent graph looks like and the points that are on the parent graph, you can just use the transformation to describe did it go left, right, up, or down. But if you don't know where the points are for the parent function, you can always find them on your own. You can create XY tables to find your points that you're going to graph. For this one, and really for any graph, I would suggest that you do some negative points and some positive points because it just gives you a nice idea of what's going to happen over time with your graph. So for this one, if I go -3 to +3, and we start plugging those into absolute value, I would take -3 plus 1, which would be a -2. But remember, it's absolute value, so it's going to become +2. What would you get if you put in a -2? 1. If you put in -1? 0. And then 1, 2, 3, 4. And so it's going to continue to start to just go up. Because it is still linear. It's like a line, but it just has two different parts to it because of that V that it's going to make. So then if I go over here and I graph these, it's going to just go up forever on both sides. So even though I only have a couple of points there, know that it's going to continue to go forever and ever and ever. Now again, I'm going to put that parent graph right on top of it. So my parent graph, I'm going to put in red here, starts at 0, 0. And then that would be if it was just y equals the absolute value of just x. And so the numbers are just going to go up one at a time on the right side and on the left side. So I'm just kind of overlaying that. You don't have to draw the parent graph on there, but I just want you to understand the red is where it would have began if nothing had happened to that x. That's like the original, like the parent, okay? And then the green one is like the child of the parent graph. It looks similar. It has a lot of the same features, but it's not exactly identical anymore. Just like us, like we look similar to our parents, but we're not identical to our parents anymore. So if you look at that, how would you guys describe what happened with the green graph compared to the red one? Yeah, it went to the left 1. And I like how you said translated because that's like the technical word for it. Translation is when you slide something around. You go left, right, up, or down. And yeah, this one just everything shifted to the left 1 space. So right here, when it says, what did the +1 do to the equation? It's going to move your graph left 1. Then it goes on and it asks about the intercepts. X-intercepts would be where it crosses the x-axis at. Where does the green graph cross the x-axis? What point? Yep. And does it have any y-intercepts? Does it cross the y-axis ever? 0, 1. So just a follow-up question on this one. What direction would it have gone if I had said in the absolute value x minus 2? It would go 2 to the right. It would go opposite. Okay, let's talk about a linear graph. So this one, we have just a regular line. This would be like y equals mx plus b. That would be the form that we're working with here for this equation. It's just a line. Do you guys remember what m stands for? Stands for slope. Slope would be what your line is doing over time. Like, is it increasing, decreasing, and how quickly is it going up or down, or is it going really slow? Do you remember what the b stands for?
The y-intercept.
The y-intercept. And that would be where the graph crosses the y-axis at. So when we look at this, we should be able to figure out, just by looking at the picture of a graph, where the x-intercept would be, where the y-intercept would be, and so on. So where would your x-intercept be for this line? Yep. And where would be the y-intercept? Good. Then it goes on and it says, what's the slope? Well, there's a couple ways that you guys could find slope. There's a formula. Like you could do y2 minus y1 over x2 minus x1. You've probably done that a time or two in your time at high school, where you had to find slope between points, or maybe you were given a graph or you weren't and you just had to plug in your numbers. This could also be notated as, it looks like it says triangle y and triangle x, but that's actually a Greek letter that means change. It's the Greek letter delta, and that just means the change in x and the change in the y values. But when I have a graph, I don't really need to rely necessarily on the formula. Now, if I only had points that were given to me, I had no graph to look at, then I would maybe want to use my formula here. But you should just be able to count in between those two intercepts that we found. To find your slope, remember another word for that is rise over run. So how much did it go up or down between your points, and how much did it go left or right? So from this intercept at that negative 3, 0 up to the 0, 5, this, if I start down here at the negative 3, it went up 5, and it went right 3. So I would write that as 5 over 3. You would get the same answer if you did pick those points and you plugged them into your equation. But because I have my y-intercept and my slope, I should be able to write out the equation. Because I gave you the form up here, y equals mx plus b, and we just got to plug these things in. So we said our slope was 5/3. And then the y-intercept we said was where? 0, 5. But when you plug it into your equation, you just take the y value of that coordinate. So just the 5. Or again, you just look at where does it cross the y-axis? It crosses at 5. And so that's going to be your y-intercept. All right, so we've talked about two kind of linear graphs so far. The line is linear, but also that absolute value graph was also made up of linear pieces. Let's talk about a non-linear graph. Do you guys remember what this kind of graph is called? It's quadratic. Okay, this comes from anything that has x squared involved. We would call this kind of graph a parabola. All quadratics have a parabola for a graph. All right, let's take a look here at what they're asking us about this parabola. They're asking first, what's the x-intercept? Is there more than one for this one? It crosses the x-axis how many times? Twice. Where at? Oh, careful. Look at how that graph's labeled. This is like half. This is actually 1, and then this would be 3. So where are they? Yeah, 1, 0, and 3, 0. Does it have a y-intercept?
Yeah.
At where? Good. 0, 3. Okay, it's asking next, what's the vertex of the parabola? 2, -1. That's always where, I call it kind of like the turning point of the parabola. It's that point that causes the graph to kind of decide, is it going to go up or is it going to go down? So this middle point here is 2, -1. Now they're asking at the bottom, what's the equation for this parabola? Well, there's a couple ways we could write the equation for a quadratic. We just saw a whole bunch of quadratics in the last chapter where it was like x squared plus x plus something. But we also have something called vertex form, which is helpful when you know what the vertex is. So your vertex form looks like this. Y equals x. I'm going to write this out twice because it could be x minus h and then plus k, or it could be switching the signs, x plus h and minus k. But those are both kind of your vertex form. The signs in between the x and the h and the k can be changing to pluses or minus signs. When I look at the vertex form, if there's a subtraction sign inside of our parentheses, think about when we talked about that with the absolute value graph. The one that we saw at the very beginning of the lesson was the absolute value of x plus 1. And remember that plus 1 caused it to move to the left. It's always a little bit backwards to think about that, because when we think plus, we think positive, so we automatically want to go to the right. But when it's inside parentheses like that, it's going to flip it, and it's actually going to make it go the other direction. So when I see a minus sign, I think negative, but I have to reverse it, and it's actually going to make it go to the right. So if you see a minus in front of that h, it's going to shift your graph to the right. If you see a plus, it's going to shift it to the left. The k on the outside does not do that like switch in direction. It is what it appears as. So if it's a plus k, that's going to move it up. If it's a minus k, that's going to move it down. Again, the quadratic has a parent. Now the parent graph's not on here, but let me show you where it would be. All parents would be y equals x squared for a quadratic. And they always start at 0, 0. And they have a couple of key points. You have a point at 1, 1 and -1, 1. And you have a point at 2, 4 and -2, 4. That's always what the parent of the quadratic looks like. So now if you look at the parent graph to the one in red, what directions did it move?
Left and
The green one to the red one.
right.
Yep, it went right and it went down. I'm just kind of comparing the vertexes here. It went to the right and then it went down. So now if I'm going to write my equation, like I have my vertex form up here, it's going to be y equals x. Since it goes to the right, should I have a minus sign or a plus sign? Minus. And how many to the right did the vertex go? 2. And then, oh, I forgot my squareds up here. On the outside of those parentheses, you should have squared. And then it went down 1. How would I write that? -1. All right. Last problem here says that divorce rates are considerably higher for couples who marry in their teens. The equation D equals 4n plus 5 models the percentage D of marriages that will end in divorce after n years if the wife is under 18 at the time of marriage. Determine the percentage of marriages ending in divorce after 15 years. I don't know many people who are getting married under 18 that this needed to be created, but I guess it happens. Oh, did you guys? Oh, that's so nice. Yeah, where's the marriage license?
Yeah, it's in my bedroom somewhere.
Probably with your glasses. Okay.
Oh yeah.
We want to know determine the percentage of divorce after 15 years. So where does the 15 go? In for n, because n represents years after the marriage. So we're going to take 4 times 15 plus 5. And what's that give us? Okay, and that would be
0 years old.
percent. What?
Wait, what?
No. That's saying that if someone
But
15
who's
years would have a 65% chance of being divorced. That's what the study's saying.
Okay, so. Okay.
They're saying if you got married to your wife who was under 18, then after 15 years, there's a 65% chance that you guys are no longer married.
I thought the graph was like, the bottom was like the age, and then the was like how many years. I was like,
We're just
who's
marrying
getting
off
married
people.
at 0 years old?
Okay, so now if we look here, they're asking, compare your answer to the graph, do they match? Well, they have this dot, this is in between 14 and 16, so that would be after 15. This is probably years. And then this is the percentage. And that looks like it's right in the middle. So I would say they match. All right, any questions?
Yeah, he's great.